1033, Chapter 3, Section 2, dealing with functions. First thing you need to understand is the definition of a function, and it's really pretty simple. The x's in your ordered pairs cannot be repeated. That's all there is to it. You just check your ordered pairs. If any of your x's are repeated, it's called a relation. If your x's aren't repeated, it's still a relation, but now it's a function. The domain is x, the range is y. We've already hit on that. We're going to talk about the vertical line test, which is on page 134, 135. We come over here, just some examples, just to help you get to understand. Sometimes you get a mapping diagram. This is a mapping diagram. The first set of numbers is always the input. Second set is the output. We already talked about the input is x, output is y. If we look here, all the x's have one arrow coming from them, so they're only being used once, so this is a function. And if it makes it easier for you, set them up in ordered pairs. Here's your x's, so this is A3, this is C3, this is E1. See how all my x's are different? Doesn't matter about my y's, it's just the x's. Same thing here. If we look here, we got a -3 for x, here we got a 1, here we got a 2, here we got a 3, all different function. All slope-intercept form of an equation is a function because there's only one x for every y. So any slanted line that has a positive slope, any slanted line that has a negative slope, any horizontal line that has a zero slope is a function. Just looking at some other examples here. We can check the ordered pairs here, see that 2 is repeated, so A is not a function. This is a horizontal line, all different x's, so it's a function. Looking here, see how all our inputs have one arrow drawn from them, so it is a function. Coming down here, we can see that letter A is not a function because the 4 is repeated, so it's the 5. This is a vertical line. Vertical lines are not functions because all the ordered pairs have the same x. Coming here, see how all the inputs have one line drawn from them, so this is a function. Coming over here, last example problem. Looking at the ordered pairs, we've got -2, 2, -3, 9, function. Coming here, this is not a function because we can see the 0 is repeated, so this is a relation. Coming here, if you ever get anything like this, you're not concerned with correspondence, you're not concerned with output when you're trying to determine a function. You're only looking at inputs, domain, x's. People in a certain city. Well, I haven't met anybody yet who's the same person. So people are all different, so this is a function. Next we talk about the vertical line test. The vertical line test is just where we draw an infinite amount of vertical lines, and if all our vertical lines only intersect one point on the graph, function. Here this is a function, this is not, because the vertical line intersects more than one point. Come to example problems. See how letter A is a function. All the vertical lines will only intersect one point. Letter B is a function. All the vertical lines will intersect one point. Letter C is not a function because the vertical line intersects more than one point. Coming here, it is a function. That is not a function. Remember, vertical lines are not functions. Coming down here to these. Letter A is a function. Letter B is a function. Letter C is not. Letter D is a function. Letter E is not. By the vertical line test. Next, when you look at graphs, you got to be able to determine the domain and range. Domain of a graph is from the smallest x in your ordered pairs to the largest x in your ordered pairs. So horizontal distance. So you can see that my smallest x is a -3. My largest x is a 5 in this graph. So my domain is bracket because we're using the -3, comma 5, bracket because we're using the 5. Range is always the vertical distance from the smallest y to the biggest y. So remember, domain is x's, range is y's, from smallest to largest. So our smallest y is a -2, our largest y is a 4, so our range becomes bracket -2, comma 4, bracket. Again, we're using brackets because we're using the negative 2 and the 4. If we come over to these, we can look at these graphs. All the same thing. My smallest x is a negative 1. My largest x is a 2. So here's my domain, negative 1, 2. My smallest y is a negative 2. My largest y is a 9. So here's my range, 2, 9. This is a function by the vertical line test. Coming over here. My smallest x is a negative 1. My largest x is a 1. So there's my domain, negative 1, 1. My smallest y is a negative 4. My largest y is a 4. There's my range, negative 4, 4. This is not a function by the vertical line test. Now these become a little more difficult because whenever you have the arrows here at the end, that means that it's going to go on down forever and to the left forever. This side's going to go down forever and to the right forever. So that's the reason our domain is all real numbers. It's negative infinity to positive infinity. Our range, however, comes from negative infinity and stops at 4. And in this, all straight lines, all linear equations. The domain is negative infinity to positive infinity, which means all real numbers. The range is negative infinity to positive infinity, which means all real numbers. Next, we talk about function notation. Make sure you understand that function notation means some letter, usually F or G or H, parentheses X. Y equals F of X. That's the way we refer to this. We substitute a number in for X, which means then we substitute that same number in the equation, solve, and now we get Y. This gives us an ordered pair. Anytime we pick X and solve, we get Y, so we get an ordered pair. Here's example 7 in the book. It tells us that f of x is 7x squared minus 3x plus 1. G of x is 8x minus 2. First problem. Find f of 1. Find f of 1. So what we do is because the 1 took the place of the x here, the 1's going to have to take the place of all the x's in the equation. Do the math, we get 5. We get the ordered pair 1 for x, 5 for y. Anytime we solve a function for a value, it's a y. Because remember, f of x is y. Here we want g of 1. So we put a 1 in there, do the math, we get 1, 6 because we get y equals 6. Over here, f of negative 2, we put negative 2 in for x, do the math, we get 35. So we get negative 2, 35. And here we get g of 0, let's put 0 in there, we get 0, negative 2. Remember we talked about this. A 0 in the x position is a y-intercept. A 0 in the y position is an x-intercept. And when you solve these problems, I'm going to want to see it written as an ordered pair, not as f of x equals, f of negative 2 equals. I want to see that you know that these two numbers right here are the ordered pair, negative 2, 35. Last thing we have to cover is example 8 in your book. And basically what this is dealing with is this. Finding an x or a y on a graph. All right, so here's the problem. Here is f of x. This is the graph f of x. This is the graph g of x. This is asking us to find f of 4. Well, the 4 is taking the place of the x. So we find the 4 on the graph, on the axis, x-axis. Follow it up to the graph, then follow it over, and we find f of 4 is equal to 2. Because it's the ordered pair 4, 2. If we want f of negative 2, find negative 2 here, follow it up, follow it over, f of negative 2 is 1. G of 5, now we're on G. So here's 5. If we follow it up, we can see that it's intersecting at 3. If we want G of 0, here's 0, it's actually equal to 0. Working reverse, this is saying find all x values such that f of x equals 1. Remember what f of x is? It's y. So this is saying find all the values for x where y equals 1. So we're back on f of x. So here's 1 for y. Follow this way, and we get, I think we get 2, negative 2. Follow this way, we get 2. So negative 2, 1, 2, 1 are the values that will make f of x 1. When we come to g of x equals 0, here's 0. Well, when y is 0, so is x. It's 0 as well. Remember, f of x, g of x all mean y. So this is really saying y equals 1. So what are the x's? Y equals 0 on g of x. So what are the x's? Let's just finish this by looking at these. Here's f of x. Here's g of x. So what we're looking at here is they want us to find f of 1. So they want us to find what is y when x is 1. So if I put 1 here and follow it down to right here, follow it over, I can see it's negative 3. Here they want me to find f of 0. Well, they're saying when x is 0, which is here, what's y? Negative 2. Here they want me to find g of negative 2. So here's negative 2 for x. Follow it up, and we get 3. They want us to find g of 0. Well, here's 0. Follow it up, 1. Remember, this is the reverse. When it says f of x equals 1, it's saying y equals 1 for f. So when y equals 1, which is right here, follow it over, we get negative 1. Follow this over, we get 3. So we have negative 1, 1, we have 3, 1. If we want g of x equaling negative 2, we're looking for y equals negative 2. So here's negative 2. We follow it over, we find out that it's negative 3. So it's the ordered pair negative 3, negative 2. And I know the answers here in the book are showing just regular answers, but I always want the answers as ordered pairs.